Hi everyone, Mr. Boltri here bringing you video 1.7 where we're going to talk about dimensional analysis. So today we're going to talk about what is dimensional analysis and why is it useful. And why is it useful? We're going to go through two examples of when you can use dimensional analysis. First being unit conversions and second being when we're trying to figure out what something means. So first, what is dimensional analysis? Well, let's look at the words. Dimensions is just a fancy science word for units. And you guys know what analysis is. It's just by looking at or investigating the units. So today we're just going to look at a bunch of units and see how they are useful. So first example of how it's useful is when we're trying to do a unit conversion. And let's say that you were doing the circles lab and you measured the diameter in inches instead of in centimeters. So in order to be able to share those results with your group, you're going to have to convert the inches into centimeters. You're going to have to change the unit without actually changing the length of the thing. So in order to do that, you might have to look up the fact that there are 2.54 centimeters in 1 inch, but then how do you convert 5 inches into the appropriate number of centimeters? Well, in order to do that, first, let's remember something from math class. If we multiply a number by 1, it doesn't change that number at all. 5 times 1 is still 5. That's just kind of a basic rule from math class. And that 1 doesn't have to just look like the basic number 1. It could look a little bit more complicated, like 4 divided by 4 is still 1. So when we multiply 5 times 4 divided by 4, we get 20 over 4, which still equals 5. We haven't changed the 5 at all by multiplying by a 1, even if that 1 looks a little bit more complicated. And the 1 could look actually really crazy. 2 squared divided by the square root of 16. If that's still 1, we could do all the math all the way through and still realize that we haven't changed the number 5 at all. So what's that have to do with dimensional analysis and unit conversions? Well, let's go back to that 1 inch equals 2.54 centimeters. So we can set up two sort of fractions, 1 inch divided by 2.54 centimeters. If these two things are equal, then this is going to equal 1. Same thing over here. 2.54 centimeters divided by 1 inch, that equals 1 because these two things are the same. So the same thing divided by itself equals 1. So we could take one of these and multiply it by 5 inches, and that would just be multiplying by 1, so we wouldn't actually be changing the 5 inches at all. But the question is, which of these two should we multiply by? And in order to answer that question, that's where we get into dimensional analysis. So let's just look at the units. So let's see. Let's just look at what it looks like. If we take inches and multiply by this conversion factor, do we end up with centimeters? I should put like a question mark over here. And then over here, if we take this and multiply by the inches and multiply by this conversion factor, do we actually end up with what we want, which is centimeters? So I hope that you can see that if we multiply by this on the top, inches times inch is going to give us inch squared divided by centimeters. We don't want inches squared divided by centimeters. Here we have inches in the numerator, inches in the denominator. So those are going to cancel out, and then we're only going to be left with centimeters. So this is the correct conversion factor to multiply by. Because if by dimensional analysis, if we look at the units cancel out. The units that we want to get rid of cancel out, and we're left with only the unit that we want to be left with. So then we can actually plug in the numbers. 5 inches times 2.54 centimeters divided by 1 inch. Remember, this is 1. So we're not actually changing the length at all. And we get 12.7 centimeters equals 5 inches, which we can actually check on a ruler. 5 inches is right at 12.7 centimeters. So it does work out. We haven't changed 5 inches at all. We've just converted between the units. So now let's talk about a specific instance of unit conversions, which is metric conversions. So you don't have to memorize a conversion factor like 2.54 centimeters equals 1 inch, but there are 3 conversion factors which you are going to need to memorize. And so here you see 1, 2, 3. There's several, the metric conversions, kilo, hecto, deca, deci, centi, milli. There's like a lot of memory tricks you can Google out there to remember these. There's King Henry died by drinking chocolate milk, but then you have to remember that. And honestly, I'm going to be completely honest with you guys. I've never seen in all of my years working with science, except like just a practice problem that uses hecto, deca, or deci. So I'm not even going to ask you to memorize those. I'm just going to ask you to memorize the ones that are kind of the most important for you to remember. So kilo, centi, and milli. And these come up most commonly in like millimeters, centimeters, and kilometers. But it can also work for like milliliters, centiliters, and kiloliters, or whatever. So your base unit could be meters or liters or whatever. But these are really the only three that I'm going to ask that you just memorize. And one easy way to memorize them is to think about, well, how many centimeters are in a meter stick? We've all worked with meter sticks before, and I hope you can remember there's 100 centimeters in a meter stick. So using that, there's 10 millimeters per 1 centimeter. So it's just that times 10, 1,000 millimeters in 1 meter. And then this, I like to think about like our cross-country runners who run a 5K, which is 5,000 meters, 5,000 meter sticks. So 1K is 1,000 meters. So just those are the three that I'm going to ask that you memorize. But any other conversion factor that you would need to know on a quiz or a test, besides for like easy things like how many days are in a year or how many seconds are in a minute, I'm going to give you any other non-obvious conversion factor besides for these three. So that's one way that dimensional analysis is useful, is in making converting from one unit to another unit. Another way that dimensional analysis is useful is if we're trying to figure out the meaning of something. So one example is the M&M's lab that we did. So you can find the slope is 0.8. But the question is, well, what does that slope mean? So we can do dimensional analysis and look at, well, what are the actual units of the slope? We found slope by doing rise divided by run. So the units are going to be grams divided by the number of M&Ms. So the slope is 0.87 grams per M&M. Or you could write that as 0.87 grams divided by 1 M&M, which allows us to more easily see, using dimensional analysis, that the meaning of the slope is the average mass per 1 M&M. So every time we add 1 M&M, on average, some are a little bit higher, some are a little bit lower, but on average, the mass of a single M&M is 0.87 grams, which we might not have been able to see had we not looked at the units. So that's another example in which dimensional analysis, aka looking at units, really helps us to solve problems. So let me know if you have any questions. We're going to do a lot of dimensional analysis practice problems in our next class. I'm just looking forward to doing some practice problems with you then, and let me know if you have any questions about how to use dimensional analysis. Go Bears.